Alright, let's continue our discussion about the mathematical foundations of this course. What we're going to talk about now is referred to as molar volume. And as you can tell from the title, what we're going to do is connect our idea of moles to volume, which has units of liters. So this will allow us to convert between liters and then moles and grams, or moles and molecules. In other words, it brings it all together. So first of all, let's talk about the conversion between moles and liters. Our sentence here says, for 1 mole of an ideal gas at 0 degrees Celsius and 1 atmosphere, the volume of the gas is 22.42 liters. Well, what that means for us is we can use the conversion 1 mole of any gas is equal to 22.4 liters. Now this is an ideal gas at standard temperature and pressure. Now for us, for right now, this isn't going to matter, but let's introduce it now so when we do talk about gases, it'll be familiar to you. What this means is, according to Avogadro's law, and we'll talk about that a little bit later, actually Avogadro's hypothesis, what we'll say is that at standard temperature, which is 0 degrees Celsius, and 1 atmosphere, which is a unit of pressure, this conversion holds true. So what we're going to assume when we do these problems is that we're at standard temperature and pressure, and we call that ideal conditions. So let's take a look at the first example. It says a sample of oxygen gas has a volume of 2.5 liters, and again, that clarification at STP. How many grams of oxygen are present? So as we did in the last podcast, let's start with the given, 2.5 liters of oxygen. Let's do our first conversion. Since we're starting with liters, we want to get rid of liters, so we're going to put that in the denominator. Now, since 1 mole is equal to 22.4 liters, we can say 1 mole of oxygen and 22.4 liters. That way our liters cancel. Now we want grams, but right now we have moles, so we need to do another conversion. So we want to get rid of that moles, so we'll put moles in the denominator. Now we know how to convert from grams to moles. 1 mole of oxygen contains 32 grams of oxygen. That way our moles cancel. We can do the math. 2.5 divided by 22.4 times 32 is going to give us 3.57 grams of O2, as you can see from the already given answer. Let's take a look at another example. Let's say we're starting with 54.3 grams of carbon dioxide, and we want to know what volume that has. Now remember, volume has a unit of liters, so let's start with the given, 54.3 grams carbon dioxide. Let's do our first conversion. Since we're starting with grams, that has to go in the numerator. Now remember, we can go from grams to moles of carbon dioxide using the molar mass. 12 plus 2 times 16 is 44 grams. Our grams cancel. Now we have moles of carbon dioxide. So we want to get rid of moles. So let's put that in the denominator. Now we can convert to liters, which is what we're trying to find, by using our conversion. 1 mole of any gas is 22.4 liters. That way the moles cancel. We can do the math. 54.3 divided by 44 times 22.4, and we get 27.6 liters of carbon dioxide. So as you can see, this conversion, 1 mole of any gas is equal to 22.4 liters, allows us to go from liters to moles, and then if we wanted to, we could go from moles to grams, or we could go from moles to molecules. And that's what we'll do in the next podcast. We're going to tie this all together so so we can do any of these conversions. So again, email your questions to Hannon in Chemistry or go to the Moodle site and post them on the forum.